Okay, welcome to Algebra 2, Unit 5, Lesson 3. This one is talking about inverse of matrix, and we're going to try using our calculator. And again, I'm going to be going through as quickly as I possibly can, and you guys will need to follow up, stop, and do the work as it goes along. Okay, to find the inverse of the matrix. Well, first of all, the matrix must be a square matrix in order to find an inverse, and its determinant cannot be the number 0. Okay, and we can write the symbol as the determinant of A. That symbol represents the determinant. The inverse. That's a matrix A with a little inverse sign right there. We can write it either way. Okay, or we can write this like this. The inverse is very similar to the way we write the inverse of the function f. Okay, if we want to do this by hand, and doing inverses by hand, really it's easy for a 2 by 2, but as it gets a little bit larger, you don't really want to do it. So here's how we do this: we diagonal down those numbers. We flip the position, so the 1 comes up here, the 3 comes down here. 1 up here, 3 down here. Okay, the diagonal going up, we switch the signs on those. Okay, we just change the sign. If that's a negative, it becomes a positive. If that's a positive, it becomes a negative. Okay, and then we divide each of the, after we've done switching the positions and changing the signs, we divide each of those by the determinant, -7 all the way down. Okay. All right, over here, matrix A, to find its inverse. Okay, the matrix A times its inverse will give you this thing called the identity matrix, where the diagonal going down are all 1s and everything else is a 0. So the resulting matrix is called the identity matrix. It's a 2 by 2. The identity matrix for a 3 by 3, right here, are 1s going down that main diagonal and everything else a 0. Okay, well, find the inverse of the following matrix. Can I find the inverse of this? No, because first of all, it's not a square matrix. Okay, so I can't find the inverse. If I want to find the inverse of this one, well, that's also not possible, because when I find the determinant of this, the determinant of this one equals 0. So I cannot also find this matrix. Cannot divide by 0, because remember, we put 0. We put the determinant on the bottom of each of these fractions. Okay. Next one. In order to find the cool thing about getting the matrices is to find the answer to our multiple variables in multiple solutions here. Okay, so this is their coefficient matrix. Just take all the numbers in front of the variables right here, put them right there. The resulting answer right there, we put them right there. Okay, and the x, y, z, since we removed them, we put them in a matrix right here. So we can say this times this equals this. Okay. The best way, the easiest way to find this is, we'll call that matrix A, we'll call that matrix B, and this is the resulting one we want to find. So we plug this into our calculator, okay, and we get the inverse of that matrix, multiply it by this matrix, and it gives us a resulting matrix. Okay, so I'm going to do that really quickly for you guys. Okay, so second matrix, we're going to call this one matrix A, so I'm going to go ahead and edit that. And I'm going to use our old matrix, so 3 by 3, and I'm going to plug it in 1, 2, -3, 2, -1, 3, 3, 1, -3. Okay, got to double check everything. Okay, it's good. Okay, second quit. Now I'm going to plug in our second matrix. This time I'm going to edit it, and I'm going to call this one matrix B. Okay, this is a 3 by 1. Okay, and it's -13, 23, -8. Okay. Oops, that was a 3 by 1, not 13. Delete that guy. Okay. So again, let's try that again. -13, 23, -8. Excellent. Okay. So here's how I do this. I go second quit, and I'm going to multiply these two matrices. So I go second matrix A, because that's what I want, and I want to find the inverse of it. I go second inverse right there. Inverse of that times second matrix, and this time I want to multiply by B. Okay, so inverse of A times B. Okay, that's what we said, inverse of A times B. We press enter, and we get the answers: 3, -1, so 3, 1, and 6. So 3 is x, 1 is y, z is 6. Okay. You want to do this again. Again, this is the coefficient matrix, so you just get 4, 6, 5, 8, 4, 6, 5, 8. The resulting matrix is this. So again, find the inverse of this, the determinant, the inverse of this matrix times this, and it'll get you negative 24 and 20. Okay. Then do the same thing. Inverse of this times this will get you this, and get these answers. Now again, I do want you guys to check all these things out and make sure you guys are doing them properly. Okay. Okay. Now if I give you guys this matrix, well obviously you know that this is your numbers going across. Okay. Second row. Okay. And so you can write this as equations. This is 2x plus 3y minus 4z equals negative 12. That's my first equation. You can work it out like this. Okay, word problems with this. Burger heaven. We have got three things. Let x represent the cheeseburgers, y the fries, z the milkshakes, and that gives you a couple of things. It says 2 cheeseburgers, 3 fries equals this. Okay. Then we have a cheeseburger and 2 milkshakes cost you this much, and so on. We write our 3 equations, and then from this we create our matrix. Okay, cheeseburgers, fries, no milkshake, and cost this much. A cheeseburger and 2 milkshakes cost this much. Cheeseburger, 2 fries, and a milkshake costs this much. Again, the inverse of this times this will give us our x, y, z. Burgers cost this much. Fries cost this much. Milkshakes cost this much. Okay, same idea. Again, work this out. We'll let this represent the 60-minute tapes, the 90-minute tapes, the 120. Okay, we set up our 3 equations. Okay, and we write them here. Oops, we write them right there. And when we plug in the inverse of this matrix times this, will give us a resulting number of tapes bought. Okay, right here, we've got the determinants. Okay, using Cramer's rule to find this. So again, determinant C, determinant X, determinant Y, determinant Z. Okay, and again, the determinant C has everything, has X, Y, and Z, but no C. Determinant X keeps the Y, keeps the Z, but replaces the X column with the constant. Determinant Y keeps the X, keeps the Z, and replaces the Y column with this constant. And determinant Z keeps the X, keeps the Y, but replaces the Z column with the C. Okay, we find the determinants of each of these. Determinant C is 5, negative 5. Determinant X is negative 25. Determinant Y is 0. Determinant Z is negative 5. Okay, we play it in order to find X. It's dx over dc, dy over dc, and dz over dc to get these answers. Always best to find the determinant constant first, because if this one ends up being a 0, then we know that none of this will work because we cannot put zeros on the bottom of the fractions. Okay? And it says, what solution is a 3-bit Unix in Y? Oh. All right, I will conclude this video, and then make sure you guys copy this information down right here. Okay, you guys can go ahead and quickly pause it, and hope you guys understood this. If not, again, look over the notes, watch a video again, and make sure you guys understand what's going on. If not, then I'll definitely be here to answer any and all questions.